Hi, this is part 2 of my Ampeg B-15N video on fault finding this thing. I found out this amplifier was probably made in about 1969, so that would explain why there's some big old capacitors like this from Sprague. Last night I made a video. I was going to test these capacitors to see what the ESR was and what the readings were, but there was a lot of voltage on these. There was 135 volts on this capacitor, and out of this one, which is a module with 3 capacitors in it, 95 volts on this. So, and they didn't discharge. I could have used this resistor I used to discharge them, but I've run out of time anyway, so I've left it off overnight, and there wasn't much voltage left in there. So what there was, I just basically used this resistor, which is a 15 ohm 10 watt, to discharge down to earth, and so they are not charged at all now. Now unfortunately I've got my fantastic DER capacitance meter here, inductance meter. I bought this directly from Japan and paid the freight because it was cheaper than buying prices on eBay UK. I bought this when I was in the UK, and it's fantastic. It served me really well. It's really accurate. I modified this guard that you got with it, the TL21 accessory. I modified it. Instead of having the short tiny little probes with the crocodile clips on, really short length that it had, I've modified it with these differential probes here. There's a video on YouTube showing you how to do that, and it's well worthwhile. So this has been calibrated. I've calibrated this to take the lead resistance out. I tried to test this just now for the camera, but I couldn't get a good enough contact to test it. But this is, I found out on the schematic that this is 30 microfarads, 600 volts, and it actually says 30-600. It's not 30 to 600 volts DC, it's 30 microfarads, 600 volts DC. You can't buy these capacitors at all. You can't get 30 microfarads, and you can't get 600 DC of anything really, as far as I can see, only 400 or 500 DC. So the only way to replace a capacitor like this would be to get 2 capacitors of double the value here, so 60 microfarads, which you can't get, so 68 microfarads. Put them in series, and you can half this. You can have 300 volts, 350. I can find 400 volts, so I could put 268 400 volts DC capacitors in series, also placing a 100k resistor between them, so that it correctly divides the voltage out between the 2 resistors and doesn't put more voltage on one capacitors, so it doesn't put more voltage on one capacitor than the other. It'll be like a potential divider to divide the voltages out between the 2 capacitors. So that's the only way around that. This upright one here is rated at 450 volts, and it looks like 340 volt capacitors in that package. So basically these capacitors would have the common earth, and if I'll just try and measure these and see what they are. They should be I think it's 40 microfarads each, so I would replace these with 47 if they needed replacing. So I'll put this on here. I've already checked this as well, if I can clamp it on here, that is. Here's one, and the other one, I'll just touch it on there. So I'm going to see what this one measures. It should be 40 microfarads there. It says OL, so try it a bit better. Okay, this should be on here now. It can't read at that frequency, so you have to change the frequency to 100 hertz or 120 hertz, which is double the tension here. Then it should be able to read it, hopefully. Can't read it for some reason. Maybe it's still got a small amount of charge in there. Ay. You have to make sure they're completely discharged. Anyway, this is another one on the board here. This is, I can read on there that it should be 10 microfarads, 100 volts. So look at this one. So it's 11 microfarads, and the ESI is 4.7 ohms, which is not too bad. This is the same read rating here. Let's see what this says. Should be 10, 100 volts. Now look, this is a different kettle of fish. It's reading 161, 4.7 microfarads, nanofarads, and 600k ohms. So that's completely knackered, this one. So this one seems all right value, but I might as well replace it anyway. They're not that expensive. 100 volts capacitors of 10 microfarads. This one here on the board that I noticed is currently measuring 26 microfarads, 9.1 ohms ESR, which is possibly okay, but again, this is supposed to be 25 microfarads. So again, I think this is only 25 volts because it's on the bias circuit, the cathode bias circuit of this. So I might as well replace that as well, although it seems to measure reasonably okay. This one up here I haven't measured. Let's see what this is, but I think this is a polypropylene, which should be generally okay. So let's just see if I can measure this. Yeah, 58k. That's not too good, is it? 40 nanofarads, so I probably need to replace that as well. 59k is very high, so yeah, that needs to be replaced as well. As I say, these ones, I'm not sure what's going on with these because I could have sworn there was no voltage on there, but let's see. Oh, there we go. 55 microfarads, 0.4 of an ohm. This is part of that module of 4 there. Should be 40. Let's try another leg here. 56 microfarad, 1.1. This probably might just about be passable. Read the last one here. 55 microfarads, 1 ohm. This one here is not too bad actually, so at a push I might be able to get away with that because it's going to be a complete pain in the arse to sort this one out. As you can see, I would have to take off the paper carefully, cut it open and stick all 3 capacitors inside of there with the, I don't need resistors on that, all 3 of them in there, which is going to be quite difficult, so I might possibly leave that, I don't know. It depends really how, it's going to be quite a job that. In here you see, this is the old rectifier diode here, and you can see what it was. They cut the glass top off. It used to be a 5Y3 rectifier diode, and they just put some normal silicon diodes in there, BY something, I can't read what it says, but I checked those diodes and they actually are okay, they're 0.5 volts, so I might leave that there. If I was to reinstate the regulator properly, which I could do, I'll ask the customer what he wants me to do, then I would obviously need to reinstate those yellow wires inside. This here, this plate here, I don't think this is original. I think someone stuck this on there and renewed these sockets. I don't know why they've done that, but I don't think that is original. These capacitors are very strange. There's 7 pins, ceramic capacitor. They've got them on each of the channels, and but these won't need replacing. They're ceramic. Ceramic are fine. This one here is a bit of a surprise because I would have thought this would have been all right, but I don't know. I'm going to recheck that one. I think that's a polypropylene. I don't think it is a. So that should have been all right. I also probably, as a precaution, better check all these polypropylene capacitors as well, because this one's got a solder burn on it, probably done in production. I certainly didn't do it. I need to check all these resistors as well to see what the values are. Normally the values go slightly high over time for carbon resistors, which these should be of that date, all carbon. It's always best to replace the carbon resistors with metal oxide ones. So anyway, this is my progress so far. I'm going to now check all the components, make a list of what I need. The best capacitors to replace any of these with are F&T. That is the best make. They're extremely expensive in Brazil, but the customer of this is the owner of the shop a couple of doors down, and he's got a very good shop. He's got one here, and he's got one in São Paulo as well, and he does a lot of good business. A lot of guitarists respect him, and he sells top of the range guitars, Fender, Gibson, and all the best amplifiers next door. So it's quite a prestigious shop for this area. And this is the actual owner of the shop's unit, so he'll want me to do the very best and fit the best components. So it's going to be F&T is the best I can find, really. Obviously got Nishikon and Rubicon are very good, and Vishay as well. Vishay, which are Philips' old brands, so could be those as well. Panasonic are quite good as well, but there's so many Chinese brands out there, and sometimes the Chinese brands will put Nishikon on there. They'll make a clone basically, and it's a nightmare at the moment, things. But yeah, first thing to do is identify what capacitors are really bad and to just replace them. And these lower value ones, like this blue one here, and these grey ones are quite cheap, so I may as well replace them anyway. This big Sprague, as I said, measured 31 mic with a low ESR, so this is probably okay. Probably might not replace this. This one as well is not measuring too bad, so at the moment I've got no I tested the heaters, and the heaters were measuring 3.4 volts instead of 6.3, so there's some problem in there somewhere. It could be a resistor, or it could be one of these capacitors which is behaving differently when it's got voltage running through it. So anyway, it's probably going to take me the best part of the morning to identify what needs to be replaced, make a list. There's no component locations on this board, so I'm going to have to just well, I know the resistor color codes off by heart, so you know that's fair enough, you know. So yeah, great. I'll make a part 3 when I get a bit further, replace a few capacitors and resistors, and then test it and see what happens. So there we go. That's the end of part 2. Thanks very much for watching.